All right, so now we're going to learn about two different types of formulas that we will use for arithmetic and geometric sequences. But in this video, we're only going to be focusing on arithmetic sequences. So one way that you can find terms in an arithmetic sequence or a geometric sequence, for example, if I had the following sequence, okay, and I asked you to find the, sixth term of the sequence. Well, right now, this would be the first term. This is the second term, third term, fourth term. If I asked you to find the sixth term, well, you could just continue this pattern, which it looks like the pattern is adding 3. So I could add 3 to get the fifth term, and I can add 3 to get the sixth term. No big deal. All right, you just continue the pattern, all right? That is essentially what we're doing there is using something called the recursive formula. We are continuing the pattern, all right? And with the recursive formula, you would need to know the previous term in a sequence to find the term you're looking for. So if you wanted to find the sixth term, you would need to know what the fifth term is, because what you're going to do is you're going to continue the pattern of adding 3 to find the sixth term. All right, so the recursive formula is essentially used for when we are finding terms where it's easy to find a lower term in the sequence. However, if I asked you to find the 150th term of this sequence, you're probably not going to want to continue the pattern 150 times. So that is when we use something called the explicit formula. And in the explicit formula, you will be able to use this formula to find any term of your sequence without needing to know the previous term. So if you wanted to find the 150th term, you do not need to know what the 149th term is in order to find the 150th term. You would just use the explicit formula. But if you wanted to use the recursive formula, you would need to know what the 149th term of the sequence is to find the 150th term. So again, the recursive formula is essentially used for when we are looking for lower term numbers. For example, the sixth term or the seventh term. That's very simple to use the recursive formula. The explicit formula is when we are trying to find high term numbers, maybe the 27th term or the 108th term. We don't want to continue our pattern for a very long time because that will take us a long time. All right. So we're going to get started with actually writing these formulas in the format of these formulas. And this is all with function notation, which we've learned already. So the recursive formula, to write the formula in a recursive type of way, what you would do is you would write a of 1. And remember, this is function notation. So what this means is that we really just want to state the first term, and the first term of this sequence is 3, but in a different sequence it might be different. So we would do a of 1 and actually write down what the first term of the sequence is. Then we would write a semicolon, all right, and we would write a of n, again function notation, is equal to a of n minus 1 plus your common difference. In this situation, your common difference would be plus 3, so we would write a plus 3. This is how we report the recursive formula. How we report the explicit formula is we write the formula in function notation. A of n is equal to your first term, which is a of 1, plus your common difference times n minus 1. All right, so we're going to get some practice with this. Looking at numbers 1 through 4, we want to write the recursive formula, and the explicit formula for each of these sequences. Let's do the recursive formula first, and let's label our work. So I'm going to do R for recursive formula. Let's write the recursive formula. How we do this is we write a of 1 is equal to -3, because that's our first term. Then we draw a semicolon, and we write a of n is equal to a of n minus 1 plus your common difference, which in this case is a -4. I'm adding -4 every time, so we're going to write -4, because that's the same thing as plus -4. This is your recursive formula. You just leave it like this. Basically, what this formula is telling you is that my first term is -3, and we're going to be adding -4 every time to find each term in my sequence. All right, so same thing with number 2. Let's just do all the recursive formulas first. So my recursive formula for number 2, how we report it, because I'm going to ask you to write the recursive formula, and how you report the recursive formula is you write a of 1 is equal to, and then you state the first term of your sequence, which in this case is 7, and then you draw a semicolon. Then we write a of n is equal to a of n minus 1, and then we add our common difference, which in this case is 2. So I'm going to add 2. And that's it. That's all you do. You leave the formula like that. Sometimes you might see the formula where these two things are switched around, and that's completely okay too. All right, so that's fine to do it that way. All right, number 3, let's do the recursive formula. Your recursive formula for the arithmetic sequence is a of 1 is equal to, and then you report your first term, which in this case is 6. Then we draw a semicolon, and we write a of n is equal to a of n minus 1 plus your common difference. In this case, we're adding 7 every time, so I'm going to add 7 on the end of the recursive formula. All right, and then the next one, writing the recursive formula, I want a of 1 is equal to, then we report our first term, which is 9, and I draw a semicolon, and I draw a of n is equal to a of n minus 1 plus a -8, which is the same thing as just -8. All right, that's how we write the recursive formula. That's the same pattern you will use to write the recursive formula if I asked you for an arithmetic sequence. Now we're going to do the explicit formula. The explicit formula is the one that we will use most often, because again, you do not need to know the previous term of your sequence to find a term in your sequence like you do for the recursive formula. All right, so for the explicit formula, here's how we report it. A of n is equal to, and then we actually write our first term, which in this case is -3, and then we do our common difference, which in this case is -4 times n minus 1. And that's it. You leave it like that. All right. Number 2, your explicit formula would be a of n is equal to, we actually report our first term, which is 7. We add our common difference, and we multiply that common difference times n minus 1. Number 3, same thing. We do a of n is equal to our first term, which is 6, plus your common difference, which is 7, times n minus 1. And then number 4, same thing, a of n is equal to your first term, which is 9, plus your common difference, which in this case is -8, times n minus 1. And that's it for the explicit formula. Now, in the next question, it says find the 7th term for number 3. Since the 7th term is a low term number, we are going to use the recursive formula. Right now, my first term is 6. What I'm doing is adding 7 every time. My second term is 13, my third term is 20, my fourth term is 27. So to find my fifth term, I do 27 plus 7, which would be 34. To find my sixth term, I add 7 onto that, which would be 41. To find my seventh term, I add 7 onto that, which would be 48. So the seventh term of the sequence for number 3 is 48, and we found that using the recursive formula. Now, the next question says we want to find the 38th term for number 4. I don't know about you, but I'm not going to want to do this sequence 38 times. So I'm going to use the explicit formula. And what we do is we take 38 and we put it in for n in my equation, my explicit formula equation. So I have a of 38. All that means is I'm finding the 38th term. And I have a 9 minus an 8 times a 38 minus 1. We are going to follow the order of operations, which we're only going to focus on the right side. This left side is just function notation. We don't have to do anything with it. All that means is we're finding the 38th term of the sequence. So following the order of operations, we're going to do parentheses first. So I have a 9 minus an 8 times a 37. Next, we're going to do the multiplication. So I really have a 9 minus and an 8 times a 37 in my calculator is a 296. And then lastly, we actually simplify a 9 minus a 296 to get a negative 287. That is the 38th term of the sequence for number 4. All right, now in numbers 5 and 6, we have the recursive formula. We want to write the explicit formula given the recursive formula. So again, up here, I told you in the recursive formula, oops, these two things can be flipped around, which is exactly what you see in numbers 5 and 6, so don't be confused here. A of 1 is equal to 7.3. That's your first term. The plus 3.4 is your common difference. That is all we need to write our equation for the explicit formula. The explicit formula is A of n is equal to your first term, which is 7.3, plus your common difference, which is 3.4, times n minus 1. That's your explicit formula. Number 6, same thing. My first term is this 0.3. My common difference is minus 0.3. So writing my explicit formula, I just write A of n is equal to my first term, which is 0.3, plus my common difference, which is actually just a minus 0.3, times n minus 1. And that's it. Now in number 7, we have the explicit formula. We want to write the recursive formula. So in number 7, my first term is negative 3. My common difference is negative 5. And notice the common difference in this one is switched around with the n minus 1. That is completely okay. You could also have written your explicit formula as negative 3 minus 5 times n minus 1. That's the same thing. My recursive formula is going to be A of 1 is equal to, and then we report our first term. Then we write a semicolon. A of n is equal to A of n minus 1 plus your common difference, which in this case is negative 5, so I have a minus 5. In number 8, my first term is 4. My common difference is 1. Again, that 1 could have been written in front of the n minus 1. That means the same thing. Writing the recursive formula, we would write A of 1 is equal to 4, semicolon, A of n is equal to A of n minus 1 plus your common difference, which is 1. And that brings us to the end of this lesson. Please move on to video 2 for geometric sequences.